There you go. Got some pennies, grab one. We started a discussion on Wednesday I want to finish before we go any further. The discussion we started on Wednesday was, what does it mean? What is the well, actually, let's ask two questions. What is the probability of rolling a 3 on a single die? And actually, the discussion we're having today will help you do a quiz for Wednesday as well. One of the quizzes on Wednesday involves probabilities and spinning and things like that. So you've got two dice in front of you. Just look at one of them for right now. If you throw a single die, what's the chance you get a 3?
1 out of 6.
1 in 6. 1 in 6.
On average, over time, 1 out of 6.
But what's the probability? I like your interpretation of it. Thank you, Eric. But just what is the probability? It's
1 out of 6.
now. I had a couple of questions, and I apologize for not getting these answers to you guys more quickly. You don't have to write them as fractions. You can also write them as percentages and decimals. And I think we actually did an experiment in class last time where you guys would roll a die and we'd write down how many of you got 3s or whatever it was. So what is 1/6 about equal to as a percentage? Do you remember?
1.
Very nice. It's about 16.7%, or as a decimal, 0.167. And I don't care which of those you use. 1 in 6 is exact. The other ones are rounded, but they're all correct. Is that fair? And the only reason I bring this up is it's one of those things that gets lost in our wonderful mathematical / algebraic vocabulary. We forget things like percentages. And it's just a shame. It's just a shame. We were talking about this before, Aaron, about the percentages versus the fractions. I want to make sure that they're all legit. But now I want to know what they all mean. When you say the chance of rolling a 3 is 1 in 6, what do you mean by that? What does that mean? What does that mean? How does the 1 in the 6 play in? Will, please, give me a hand. There are, excellent. Faith, that was it's called the classical interpretation, and it's gorgeous. If you have a coin that has 6 sides, i.e. a die, and all 6 sides are equally likely, then out of the 6 equally likely outcomes, exactly one of them is a 3. And I think we broke those down on Wednesday to what's called the sample space and the event space. Perfectly said. That's a perfect classical interpretation. I love it. So that's the classical, and it works great as long as you're talking about coins. As long as you're talking about coins. And when I say coin, I mean any event that has equally likely outcomes. Like flipping a coin, rolling a 6-sided die. That quiz for Wednesday, if you do it, it's got a spinner with 10 numbers on it that are all equally sized. It does tend to break down, though, unfortunately, as soon as you apply it to stuff that doesn't have equally sized things. Like a roulette wheel, where you're betting on black. Right? What's the chance if you bet on a roulette wheel? What's the chance if you win if you bet on black?
1 out of 4.
Why 1 out of 4?
Is there 4 colors?
There are 3 colors.
Oh, 1 out of 3.
But it's not 1 out of 3. Damn it. It's actually much better than 1 out of 3. Well, I shouldn't say much. It's
like
better.
48% or something.
Why? Why is it 48%? Where did 48% come from?
Well, because there's black and reds, and then there's the zeros.
Well, that's 3, right?
They're not equal now.
Yeah, but
Boom! That's the breakdown right there, Taryn and Chad. Thank you guys. I'm going to pull a picture of a roulette wheel up so you guys can see it. The problem is,
My money at good.
you can't see this. Sorry, turn the projector on.
This is what my
The problem, the classical definition works great so long as you have equally likely outcomes. And but then it breaks down. Now there are different roulette wheels. There's American and there's also English or European. We'll go with American. Here, that's actually English. It's got 1 0. That's English or European. Where? Let's go American roulette. Here we go. American. Samaritan. There we go. That's not American. Here it is. There's an American roulette wheel right there. Is that big enough to see? Let's make it bigger, maybe. Okay. There we go.
Yeah, let me just pick a random number and hope to God I get it.
Well, and that's one way to bet, right? And if you are simply betting on one of the numbers on this wheel, Faith, Will, your definition still applies. It's a 38-sided coin. The highest number is 36 as far as numbers go. But then there's 37 and 38. There are 38 different positions. And look at all those positions. They're all equally sized. So if you were simply betting on a number, it's a 1 in 38 chance. 38 equally sized chunks, one of which is the number you bet on. Yes? Totally fine, which means your guys' definition, what's called the classical definition, totally legit. But what if you bet on red or black? Well, then it breaks down, right? Because there are three colors on the wheel, yes? There are black, there are red, but there are also green. Now, it's tempting to say it's 1 and 3 because there are 3 outcomes, but they're not equally likely outcomes. That's the difference, yes? Of the 38 outcomes, I want to take to my math here, 2 of them are green, which means you've got a 2 in 38 or 1 in 19th chance of getting green. You've got the remainder, which is what? There's 18 of each of the remaining colors, 18 red and 18 black. So the chance of getting black or red is 18 out of 38. Follow the logic on that. There's 38 total spots. 18 are red, 18 are black, and 2 are green. Because those numbers aren't the same, we can't go after the uniformly likely, there's 3 outcomes. There are 3 outcomes, but they're not equally likely anymore. That's the difference.
So you have like a 5% chance
Of getting green, which makes perfect sense. You got a 5% chance of getting green, which means the other 95% has to be split between the red and the black, which is just about 48, like Chad said, closer to 45.5 or something like that, but damn close.
So you don't get a higher payout for getting a color, but you get more payout.
You get a higher payout for betting on green and winning than you get betting on red and winning, because it's harder to get green. Because you lose more frequently trying to get green. Anyway, that's Wednesday. I saved that for Wednesday because that's kind of the point, is being able to make sure you understand how the bets and payouts work in Vegas. So, the reason I bring this up, and thank you guys for saying that again, is there another way to view this 1 and 6 over here? So let's go back over to the dice again. Is there another way to view that 1 and 6 besides there are 6 equally likely outcomes? One of them is 3. That's perfectly legit. But is there another way to view it without using the number of outcomes? And just say using the percentage? Please, Randall.
You, out of 1,000 trials, you get 167.
Thank you. Where? When? Don't answer that question. Good. Well, here Randall just said, he said out of 1,000 trials, on roughly 167 of them, you're going to see 3s. On 167, you're going to also see
1,
1s. 167 of them, you're going to also see
2,
4s, 2s, 6s and 5s. But here's the deal. How are they going to show up in the 1,000? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. What are they most likely going to do? And define. What are they most likely going to do? They're going to cluster, they're going to repeat. Yes, that was the point of 2 weeks ago when you guys were rolling dice, flipping coins. They cluster together, yeah? Michelle, that was the point of my email to you. When you see it, you'll see what I'm talking about. But the point is, it's too hard for them not to repeat. Remember the birthdays? Your birthday, essentially, is like rolling a 365-sided die. I mean, essentially. You can argue that because it's technically 9 months after your parents, you know. But whatever. It's like rolling a 1 in 365. But yet, even though that's that, we still had both the same birthdays in here. Why? Because it's too hard not to. It's too hard not to get clumps. I hear people testing me right now. Very, very good. Please do. I built the simulator to kind of show it to you. So take a look at this up here. I think this will help us visualize.